Uh, Welcome back to Tebi Talks. In our today's lesson, we are going to look at stoichiometry. Now, the question is, what is stoichiometry? When we say stoichiometry, we basically mean the relationship between reactants and products in a chemical reaction. So we have said that this is the relationship. This is the relationship between reactants and products in a chemical equation. That is what stoichiometry is all about. Now, what is the essence of stoichiometry? We're going to use the relationship between reactants and products to calculate maybe the amount of substance that can be produced when a given volume reacts with one another. Now, one application of stoichiometry, let us look at calculating masses of reactants. Calculating masses of reactants and products. So here we shall look at a simple example. The example says that calculate the mass of ammonia. Calculate the mass of ammonia gas that can be prepared from 100 grams of nitrogen, full stop, bracket, nitrogen is 14, then hydrogen equal to 1, and they gave us the equation of reaction between nitrogen and hydrogen leading to the formation of ammonia gas. So nitrogen is 2 here, this should be, this makes this 6, then 3. So this is the equation that we are given, and they are saying that now, let's calculate the amount of ammonia that can be prepared from 100 grams of nitrogen gas. Now you remember in the previous clip, we looked at interpretation of chemical equations, and when we were interpreting them, we looked at the various ways of how we can interpret those chemical equations. One of them was mass interpretation. Now here, since they are talking of mass of nitrogen, so it means that we are going to look at the mass interpretation of the equation. Now, when we look at our equation and we talk of the mass interpretation, we realize that this is nitrogen, which is 14, and we have 2 atoms of nitrogen. This becomes 28, and it is giving us this amount of ammonia. And if you can look at this ammonia, if we can calculate its RMF, we are getting something, shall get something like it. I think that is 34. So let's try to first look at that. Let's first find the relative formula mass of ammonia, sorry. So ammonia, this is 14 plus 3. This gives me 17, but it is times 2. Therefore, I get 34. Now, let's answer the question from first principle. We are seeing that 28 grams of nitrogen, 28 grams of nitrogen produce 34 grams of ammonia. So the question said, how much ammonia are we going to produce if we use the 100 grams of ammonia? Now, if 28 produce that, then 100 grams of ammonia will produce 100 times 34 divided by 28 grams of ammonia. Now let's calculate. When we say 100 times 34 divided by 28, so we realize that we shall produce 121.4 grams of ammonia. So this is the amount of ammonia, or the mass of ammonia that would be prepared in the Haber process. Remember, this is the Haber process. That is the amount of ammonia that would be prepared in the Haber process if we used 100 grams of nitrogen. So this has been example 1. Let's summarily look at example 2. And of course, this work has not really changed. It has not changed from the usual work that we had or we studied in the nothing level, I mean in O level. It is pretty much the same. Now let's look at question 2. Question 2 says that hydrogen chloride gas can be prepared by the following reactions. Hydrogen, get a better marker.
Red.
Hydrogen chloride gas can be prepared by the reaction between sodium chloride and sulfuric acid This is aqueous, giving us hydrogen chloride gas plus sodium hydrogen sulfate. Now this is an equation that is leading to the manufacture of hydrogen chloride. Now the question says that what mass of sodium chloride, question, what mass of sodium chloride is required for the production of 10 decimeters cubed of hydrogen chloride gas. Hydrogen chloride gas at STP. So there is our question. They want us to calculate the mass of sodium hydrogen chloride that is required to produce 10 decimeter cubed of hydrogen chloride. Rest P. Now, again, we come back to interpretation of equations. This is sodium chloride that is reacting with sulfuric acid to give us this hydrogen, the hydrogen chloride. But when we interpret this, we realize they are talking of mass, meaning we are interpreting this as mass and looking at this one in terms of volume. And you remember the units of volume are either liters or decimeters, cubed or cubic centimeters, or anything that is in line with that is accepted. So now, let's look at our equation. You can say solution here. When we analyze the question, we realize that 1 mole of sodium chloride produces 1 mole of hydrogen chloride gas. Now, if 1 mole of sodium chloride produces 1 mole of hydrogen chloride gas, the other question now, since they asked for the volume of hydrogen chloride, we must know how much volume is occupied by 1 mole. Okay? We must know that how much volume is occupied by 1 mole, and then which mass is producing this 1 mole. So we begin by getting the molar mass of sodium chloride. Now, we know that sodium is 23 plus chlorine, which is 35.5. This gives me a total of 58.5. Now, when we look at this relationship, we realize that 1 mole is being produced by 58.5 grams of sodium chloride. Now, how do we approach the question from first principles? We are going to say that, now I said since we are looking for this in terms of volume, then we are going to say that 22.4 decimeters cubed of hydrogen chloride are produced by 58.5 grams of sodium chloride. Now, our question was interested in 10 decimeters cubed of hydrogen chloride. Therefore, here we are going to say that this implies that 10 decimeters cubed of hydrogen chloride gas are produced by 10 times 58.5 divided by 24.4 grams of sodium chloride. You can get our calculator and compute. This is 10 times 58.5 divided by 22.4. This gives me my answer is 26.1 grams of sodium chloride. So this is just basically a simple thing, but don't take it for granted. We need to take them serious. These are just first principles interpretation of equations. Thank you for following. we meet in the next video.